Hello everyone, my name is Amar Aouzelleg, and I have prepared this mini lecture on chocolate science, which will be illustrated by an activity that my colleagues Valia and Barry have prepared. So there are 2 videos plus a resource for you to look at an activity. So the things we will cover in this short lecture are the process of manufacturing chocolate, the structure of fat in the chocolate, because that's very important for quality, and the sensory properties. So this is a diagram of chocolate manufacture. So it starts with a cocoa pod here, inside which we have the beans, cocoa beans. So the first stage is to ferment to create some of the flavor. Then this is followed by drying and more flavor creation through roasting. So each of the beans are surrounded by a shell. So we separate the shell from the bean, and we have a grinding stage, which leads to a liquid called cocoa liquor, so a thick liquid. This can be directly used as an ingredient for chocolate manufacture. So part of it is used for that purpose, and part of it is put through a press, which will separate the solid, which is a cocoa powder, which can be then used for drinking chocolate, and the cocoa butter, which can itself be used as an ingredient to further manufacture chocolate. So the ingredients are mixed. So in addition, we could have sugar, for example, or milk powder at this stage, depending on the type of chocolate we're manufacturing. So this is a general diagram, but it can be adapted for different chocolate. Then once we have this mix, we have a refiner. Here, the mixture is put through a stage where we are going to reduce the size of the particles. We are very sensitive in our tongue and mouth. We can detect particles as low as 30 micrometers, and we will call that chocolate gritty, while if we have something less than 25 micrometers in particle size, we will call that product creamy. So we want very low levels, sizes of particles. Then we have a stage which is conching, where the product is mixed for several hours, exposed to the atmosphere. So that allows the viscosity to change, and also some of the off flavor to go into the atmosphere. And an important stage here is tempering. We are crystallizing the fat which is present in the chocolate, in the cocoa butter, and that's one of the elements we will be looking at during this presentation. And the final stage is molding, where we are creating the chocolate we want. We could also enrobe products, so we can do different things with that chocolate. We can put it around cereal bars, for example. But here, an example is molding. So one of the important elements is the fat in the chocolate. So really, chocolate is a fat with things inside that fat, like other ingredients, but it's mainly fat. So it's very important to control the structure of that fat in order to get the quality we want. So most of the fat in cocoa butter is represented by triglycerides. So you don't have to know this, but we have 3 fatty acids here, which are attached to a glycerol. These fatty acids can be different. They can have carbon chain that is more or less long. They can be saturated or unsaturated. So different cocoa beans from different parts of the world will have a different composition, and that will affect the quality of the product, how it melts, for example, in our mouth. But in addition, even if we don't change the composition, even if we have a single type of triglyceride, they will be differing depending on how they come together. So they will be forming crystals, and that will dictate also the quality of the chocolate. So each of these triglycerides will have properties in terms of melting points, and also as they come together in different crystal type, they will also melt at different temperatures. And one of the job in the chocolate manufacturer is to make sure that we have a single type of crystals, which is type 5, which we will see in the next slide, in another slide, where we have something that's melting at a relatively high temperature in the mouth and give a nice eating experience. So getting the right crystal type will actually affect a lot of properties, and this will lead to a nice eating experience. So visually, a nice gloss, nice snap, good texture, cool melting, because as the crystals melt, there will be a cooling effect in the mouth because the heat to melt these crystals is taken from the mouth. There's also an effect on the shelf life, which we will see later. These crystals are all different, and they may change the visual aspect of the chocolate over time. So very important to have these crystals of the right type in our chocolate. So this is called polymorphism, so several morphism shapes. So we can crystallize the fat in different forms. So they all have different properties, and one of the important one is that they are more or less dense, so harder to melt, so higher melting point, and hence some of them are more stable. So we want something that obviously is not too soft, but not too hard, and something that gives the best melting experience in the mouth. And as you will see in your little experiment linked to this video, this will affect the flavor and how we experience the chocolate. So here we have our triglyceride again, and these will come together depending on the angle they come together, and there may be a tilt, the arrangement of the atoms. We will have crystals that are more or less dense. So we are not changing the molecule itself. The same molecules come together, but it's the way they arrange themselves that gives rise to different properties. So a good analogy will be with carbon. So here we have diamond and graphite. So although they are made of the same atom, the way they come together will give a very strong structure for diamond and a weaker structure for graphite. So here it's the same, it's similar. It's an arrangement of the molecules that gives ultimately the property. So 5 different types of crystals, so denoted 1 to 6, denoted 1 to 6. But the one we want is type 5, so which is melting. So this temperature, it's a range, so it's 33 degrees, but it's around that. It will depend on the other ingredients and specifically whether we have other fats present, maybe from the milk that is added. But it will be around 30 to 33 degrees. So here type 1 will be too low in terms of the melting point. So you can see that if we have a room temperature at 20 degrees, this will be liquid at that temperature. And then we are going to the type 6, which is a high melting point. So what will occur over time? So as I said, we want our type 5 crystals, and on the right-hand side, we have type 5 crystals that have been created on that chocolate. So this chocolate has been tempered appropriately. So throughout the mass, we have the right crystals, type 5. So this was done through the tempering stage, where we used a temperature control step, where we melted all the crystals present during that operation, and we allowed to only the type 5 to be created. So there's a temperature profile of heating, cooling, and then heating again. So we have the nice properties that we mentioned earlier, with a glossy look and the nice melting and so on. As we saw earlier, the more dense and the higher level are actually more stable. So over time, the type 5 crystals will transform into type 6. And what will happen is that there will be a change in the profile of the crystals. Some of these fat will melt and go to the surface, where it will crystallize. So on the left-hand side, we have the piece of chocolate that looks like it is moldy on the surface, but it's not mold, it's not microbiological, this is physical. So the fat melted, went to the surface and crystallized again. So here, these little peaks or unevenness on the surface is scattering light, and it looks white because of that. So it's not a safety concern, it's just a quality concern, but that's enough for consumers to reject the product. So this is called fat bloom, and the manufacturer, knowing that this will happen in any case because type 6 crystals are more stable, will set the shelf life so that consumers will enjoy the chocolate while it is with the type 5 crystals. But if you temperature abuse, for example, your chocolate, this may accelerate this phenomenon, and this may occur earlier. So moving on to a sensory analysis. So in your experiment, you are going to use your senses to analyze the product. So we use all our senses for chocolate assessment. So even the ear is used, because our jaw transfers vibration to our ear, and that will give us an idea of the texture of a product. So for example, for crisp, we can detect whether they're stale or not just because of the sound. So visual, obviously, with the color and the gloss, as we saw. Touch, our hands, but also our lips and inside our mouth. So all these are and how we handle the product in our mouth, and the melting point and so on, the texture. And the taste, our tongue, and smell with our nose. So most of what we call taste in everyday language is actually a smell. So when we say that something tastes of orange juice, for example, or of chocolate, what we are detecting is a smell. So it smells of orange, it smells of chocolate. Our tongue is very limited in terms of the detection of taste. So you all know the taste, so sweetness and bitterness and saltiness and so on. So it's very limited compared to the thousands of smells we can detect through our nose. So and when we have a cold, for example, all we can detect is the taste, not the smell, when we have the blocked nose. So that shows how limited it is in terms of the information. So we can assess chocolate using all our senses, and you will be doing an experiment where you will look at the effect of melting chocolate in our mouth and the effect on flavor, and you will see that will have an effect on the way we detect the flavor, even if it's exactly the same chocolate. So there are different types of sensory tests that we can do. So we distinguish them depending on whether people are trained or not. So usually when we have a small amount of training, that's for discrimination. So we're asking people whether they can tell the difference between two products, or whether they can't tell the difference. So that's a different similarity test. So you may have product A and B, and we give people A, and B, so 3 products, and they have to identify the odd one out. Obviously, it's all coded. They don't know, it's not A, B. They don't know which one is the odd one out, and its products are presented in the same way so that they cannot visually tell which one is different. Then we have highly trained panels, and for that we can get a picture of the product for different attributes. So those are descriptive tests. And in a way, the test you will be doing is a simplified descriptive test, although not using trained panel, but it will be using scales between 0 and 9 or 0 and 10, or 0 and 7, where you will assess different attributes of the chocolate. And then the final type of tests are preference acceptance. Here we give products to people, and there's no right or wrong answer. We just want to know if they like the product. So they can rate on a scale in terms of how much they like the product, or they can tell us which product they prefer. So if we give 2 products, A and B, or several products, they can order the products in order of preference. And you may have participated in some of these tests yourselves. So these are the 3 groups of tests. Within each, there may be different varieties. There may be a variety of tests within each of these. So to illustrate how important the chocolate melting is, you are going to carry out an activity which will be described in the next video by my colleagues Valia and Barry. So here we are not going to ask you to test tempered and not tempered chocolate with the different crystals, but we are going to have something similar. So we'll have chocolate kept at 2 temperatures, so one low and one at room temperature, and you'll be able to assess how this affects the test and other properties in your chocolate. So ideally it should be a dark chocolate, but you can do that with any chocolate really. Just that the stronger the flavor, the easier it will be to detect differences. So you cut the chocolate in half or separate in segments. Half of your chocolate will be kept at lower temperature, maybe in a fridge or in a freezer, and then the other half at room temperature. And after a while, you will be assessing these using scales for the sensory profile. So there will be a video guiding you regarding this, as I said earlier, and there will be some material that is available for you to describe the activity. So I thank you very much for listening, and I hope you have enjoyed this short lecture on chocolate science. Thank you.